So this is the review sheet for the Power Standard 1 for the master exams. So in this Power Standard, it is important to notice that it says to draw a picture. It says do not solve. So you don't have to solve anything. You just got to draw a picture that shows that you understand what is going on in the problem. So we have a standard hoop is 10 feet above the floor. So here's your standard basketball hoop. There's the hoop. So the hoop itself is 10 feet from the floor. Okay. Then it says the player is the free throw line. Suppose the eyes of a basketball player are 6 feet above the floor. So we're going to draw a player, and their eyes are 6 feet above the floor. The player themselves is 15 feet away from the basket. Okay, we want to find the angle of elevation from the player's eyes to the center of the rim. So we're looking for this. Now the distinction between this comes in the fact that although to the top of the hoop is 10 feet, we recognize that this is 6, which means this is 4. Okay, that's an important piece for your triangle. All right, there you go. You've just drawn the picture to understand how this works. Okay, number 2, Jack and Jill recently bought a log cabin adjacent to a pond. To find the approximate length of the pond, they decide to use trigonometry. Jack spends 120 meters from the cabin. So here we have a cabin. All right, Jack is 120 meters from the cabin. Jill stands 200 meters from the cabin. Oops, it's not Jill, that's Jim. There we go. Here's the pond. And the angle formed by Jack, the cabin, and Jill is 95 degrees. So now the important piece of this is the fact that the cabin is between Jack and Jill. So here's Jack, here's Jill, but it says the cabin is in the middle, which means that's where the 95 degrees is. Okay? And there you go. That's what you've gotten. There's your picture. Number 3. After the tornado, the small tree in my neighbor's yard was leaning, so let's make a tree that's leaning. Okay, to keep it from falling, we nailed a 5-foot strap to the ground X feet from the base. So we're going to, here's your 5-foot strap. Here's X feet from the base. There's a 25-degree angle between the tree and the strap. So here's the tree and the strap. This is 25 degrees. There's a 108-degree angle between the ground and the tree. Okay. How far is the strap from the base of the tree? So we don't need to find that. We have all our information in there in our problem, and we're done. You observe 2 hot air balloons at equal altitude. So here's a hot air balloon with a basket. Here's another one with a basket. Okay. Here's our airport. It says the first balloon is 12 miles from the airport. The second is 17 miles from the airport. The observed angle between them is 70 degrees. There we go. Again, there is our picture. All right, next, number 5, a slide 33.9 meters long. So here's our ladder to go up to a slide. Oh, let's make it a straight slide. Okay, the slide itself is 3.9 meters. Makes a 35-degree angle at the ground. So there's the ground, this is 35 degrees. How many meters is the top of the slide above the ground? We want to know that distance. And that's it. I'll draw a little bottom part. All right, last one, 6. The angle of elevation from a point on the street to the top of a lamppost. So here's our street. Here's our lamppost. Oops. Okay. So point on the street to the top of the lamppost has an angle of elevation of 22 degrees. The lamppost is 8 feet tall. How far is the point on the street to the base of the lamppost? We're looking for this distance. Okay? And again, you've drawn the picture, and that's all you need to do for this power standard. All right, good luck.